Thanks for joining us today, the morning or afternoon, wherever you are in the world. I'm your host, Adam Asnes, and we're here to talk about a subject that doesn't really get that much attention. No, it's not another AI webinar, um, although it can have an impact on that for sure. We're going to talk about some nuts and bolts, which are connectors. Those are the ways that we get to data that needs to be localized. And it's often kind of overlooked, like, oh, yeah, we have a connector. And there's more to it than that. And so we have with us a very special guest. Now, before we kind of get cruising into this conversation, I just want to remind everybody, if you're here within Zoom, there's a Q&A interface, and I'd like you to use that versus the chat. It really simplifies things for me. I mean, if you just want to say hi or something, use the chat. But if you want to ask a question, which I really encourage, use the chat interface. It really helps if you have a question that comes in your mind, if you write it down right away while it's fresh. That way, and if we go over it, if that becomes the next slide or whatever, don't worry about that. I'll take care of that. But I always encourage people to write down their questions right away. Um, and I'll take those. Now, if you're on LinkedIn Live, I have Daniel standing by. He is monitoring LinkedIn Live for questions. I can't do both at the same time. So, but we will look to take your questions that way. Now, let's get started a little bit. Let me get over the presentation view. A little bit about Erik. All right. I've known Erik for quite a while, actually. He's a neighbor, not next door, but we each see each other at various walks about town. I have dogs. Erik and his wife often are walking around the neighborhood as well. So we bump into each other, and we have coffee every few Fridays together. Erik comes over to the office, and we chit chat about the industry and the like, which is a nice relationship. Erik works at Argos Multilingual, a very accomplished localization company that has quite a bit of an engineering tilt to it also. So that fits well as a localization partner with us, since Lingoport's entirely focused on software systems. And I will give myself a plug. Our Lingoport product, our localizer product, sometimes gets called a connector. It's a lot more than that, but it has that kind of Git connection at its heart. But there's just a lot more that comes for the ride with that. Anyway, Erik's been in the industry for quite a while. I think I've known you since Moravia days, possibly before RWS, a lot of good places. Um, his well, the list is pretty strong there that you can read there, including even Lionbridge. And he's got a background in AI and automation for globalization programs, and he's really one of the smart guys in the industry. So it's a pleasure to have you there. Did I embarrass you? I hope so. All right.
I'm just gonna have a hard time living up to all that, Adam. Thanks for setting the bar high.
All
Yeah.
right. All right. Well, here we go. All right. First question, just for the uninitiated, it just starts at a baseline. What are connectors and localization? And maybe you can give us a few example of common connectors and how they get used.
Yeah. So this question about a connector, I mean, it's a really good question because people throw that word around a lot without really defining what it means. And I think the problem with that is that you think, oh, we just need a connector and we can have one system talk to another, no problem. And I very often get questions from clients, do you have a connector for such and such? Can you talk to this? And the answer immediately gets complicated because the implementation of each of these systems is so varied that it becomes very challenging to disambiguate exactly what you're talking about. And what makes things harder is the systems don't necessarily use the same units. So you think about a package or a thing like a task or a job or a string. These are units that need to somehow be mapped in our industry from where they live in one place to the context and the information a translator would need, or automated or otherwise, to provide the correct translation and then to return it back to its source location. So we have standards in this industry, we have APIs, we have all these different sort of ways that systems can kind of talk to each other. But ultimately, it's a very poorly defined concept. So we end up, I was playing around with this, building an AI connector maturity model. So just as an experiment, I was breaking this down into different categories. And I think at the very basic level, a connector can be just a script that automatically uploads and downloads files for you. You could have a watch folder that, put files here, and just some brief automation says, is there a file there or not? And it moves it to a new location. On the other end of the spectrum, you have fully integrated systems in which there's live updates, metadata gets passed back and forth within seconds. There's guardrails, there's checks and balances. So it's a vast range of different things. I also like to think, there's a movie, I think it came out 85 years ago, called Fantasia. And there's that famous scene of Mickey Mouse kind of using the magic to create the brooms, and that goes out of, everything goes haywire. Any kind of automation can go haywire. And that therein lies one of the trickiest aspects of any kind of automatic sort of system like that, any kind of connector that does, it says, do this, move this here. Like, it's just like a broom moving, sweeping things from one place to another. But if you don't have a mature one, then you can run into a very complex set of problems where things are moved that aren't supposed to be moved. You have access that isn't secure. You have all kinds of risks associated with it. So anyway, that's where I'm going to start the conversation. Is there's a very complicated answer, and there's a structure to it that generally speaks to first just doing the thing, and then there's the guardrails, and then there's all the extra metadata that you associate with it. And those guardrails can be either time related, so looking for noticing, for example, that something hasn't happened, or versus too many of something has suddenly happened, to scrutinizing the content in a particular location, say, is this ready to move forward? Is there some validation possible before we move from step A to step B? Is there a file there? Is it the right language? Is there something wrong internationally with this context?
Mhm.
Yeah, yeah.
Um, you know, Along the lines of this subject, you mentioned a word, a couple of words, watched folder. And of course, the old school connector is all human based. It's let me grab this file and email it to you, or
Mhm.
or something like that, or send it to you via FTP. A watch folder is like it's really just fancy FTP, and
Mhm.
it sort of has a bad reputation, I hear sometimes, and I think it's uncalled for. Everybody like prefers an API to a watch folder, but in my experience, there's a lot of cases where the simplicity of a watch folder, that's very proven technology. It
Mhm.
just works, and it doesn't require, developers to make additions and subtractions and the like. So I'm just gonna throw that out there. It's like
Sure.
a little peeve
Yeah.
of mine,
No, it's a fair
Yeah,
point. I think watch
yeah,
folders are a very simple. It's easy for everybody to conceptualize it too. But the
right.
objects that you're putting into that container could be ready for localization or not. So you can put
Mhm.
pictures of videos of cats in there, or you could put some JSON code. Like, the watch folder itself doesn't have any structure; it's just a container where you put things. It's kind of like
Right.
a DMV, moving things from point A to point B. And I think it makes a really easy starting point bridge. And lots
Mhm.
of localization still works this way, essentially, that files are, it's like a different way of sending things via email. It's either an attachment to an email, or you're putting it in a secure location, a shared DMZ in the middle that can then both parties can
Right.
access, versus, say, one team having full access to another's to sort of bridge things that way.
Right.
Yeah.
Right. I mean, the issue with it is on its own, it's not asynchronous. And well, I think we talk about that a little later, so I'm not going to steal our own thunder. But what, while we're at it, what makes a good connector? What makes it reliable and scalable?
Uh, so it depends. And I think I kind of didn't talk about some specific types of connectors, but I did want to go back one half step and mention that there's a lot of different kinds of them. I mean, there's CMSs to TMSs, there's
Right.
product information systems, there's DAMs, there's design tools, there's design tools like Figma, that can go into these different tools. There's also knowledge base like Zendesk and ServiceNow can link
Hmm.
to different systems. And there's Git, of course, which is your specialty of handling kind of software repositories and how to move them. But okay, so the next answer to your question is what makes a good one. Um, uh, Depends on it starts varying depending on each of these different classifications. And so uh, very often you start off with is it moving the right metadata? Is it getting the right context and the right content from point A to point B? Then the next level of what makes it good it's just reliable, right? You need it to work you need it to work at day, night, you don't want to babysit it. And the exception management, a simple connector handles the simple, obvious things, but it can't handle exceptions very well. It doesn't even know what an exception is. It simply doesn't do it. It doesn't do it correctly. Getting back to our rogue broom scenario. So a good one will understand the parameters correctly and constrain and manage those inputs effectively. Then it gets smarter. It starts thinking about context and structure of the content that it's moving. So it starts looking under the hood a little. So we were using the example of throwing a JSON file into a watch folder. A smart connector might say, is it well formed? Are there issues with it? Are there some reason why this shouldn't move forward in the process? There's also smart workflows. Security is a big one. So being auth to, SSO, TLS encryptions, just something that sort of makes sure that your content is safe getting from point A to point B. The maintainability, the flexibility, and ultimately where I get super engaged is where is it creating measurable business value? So often we have kind of situations where somebody might be over-engineered for something because they have a massive amount of ecosystem to support a trickle of product. And we see the opposite problem where we have clients who are trying to essentially send hugely complex daily or monthly updates as a zipped bundle of a bunch of unfiltered resource files and just dumping them into an email or some share file and then moving them over. That creates a lot of headache. And what really gets hard is the delta management and sort of version control and delta management. So then you end up with this, you start one workflow, you make it through part of that workflow, and then you have an update. How do you keep track of what you're updating? Where are things in that process? And how do you make sure they have all had the appropriate checks and process controls and then get them back to where they live? That whole round trip. And then you start iterating those on top of each other. So especially with continuous localization programs, you have updates the dev team doesn't want to wait for the round trip to finish. They just update what they're going to do immediately, and they push a fix. How do you reconcile those update cycles? That becomes what makes it really good, I think, is being able to handle exceptions, being able to be secure, being reliable, and of course the business it's fit for use. It's sort of meeting the business requirements, and that it's smart enough to know when somebody needs to intervene. Yeah.
Yeah, the thing that like the very basic at the heart of it is automation speeds everything up. But if it passes on a critical error, you've now sped up chaos.
Yes.
And we've seen like in the really early days of Lingoport, we got called into a company that makes big yellow machinery. I won't say their name, but you can figure it out. Because of some automation, they had corrupted their entire parts database. And there was only a small percentage of corrupted data, say, 1 or 2%, but that parts database was enormous, and they couldn't figure out how they're going to detect all this and how they're going to get rid of it. But it was because of an automated process that made character corruption issues, and so we went in and fixed that successfully. But it
Yeah.
it it's just one little anecdote. But I've seen it a lot, be it like forget, like duplicate string IDs that get passed on, or a bad file format that gets passed on. And essentially, you risk minor errors to breaking source code. So your connector should have a lot of checks,
Mhm.
like your data needs to go in. And if there's an issue, it needs to show you where the issue is. So it could just be like very quickly corrected. Um,
No, that's very true. And software is
yeah.
one of those things where a single character can blow up a lot.
Right,
It can
right.
cause a lot of problems very quickly. And then when you have n number of languages you're adding on
Hmm.
top of it, you have a multiplier effect. So now you have the compounded impact of the error itself on one language, and then it
Hmm.
multiplies out to multiples. And we
Right,
we can see a situation too where a single think about the minimum charges that often are part of minimum effort to do a round cycle for certain less efficient updates.
hmm,
When you need a human to be coordinated to look at something, that has a minimum overhead to it that
hmm.
if you multiply it out, that means character, one character flaw they have to fix. If you have to send that out to n number of linguists, you could easily be talking about thousands of dollars of impact just once, just one thing that
Right,
requires
right,
a manual. Now, obviously, the way things work is release now, iterate later. Most of the time, those there are bugs. You kind of aggregate them and then you fix them in the next release type of thing. But it is important. The error handling itself becomes incredibly important upstream. The further you can move that left, the more you can be looking at how healthy the code is to begin with, and preventing things to go into the pipeline in the first place
right,
is
right.
a million, well, not millions, but many thousands of times better than fixing it after the fact. Yeah,
I'm going to mention sometimes it comes back from the linguist with a new error introduced
that's
as,
true.
as well. So it's coming and going,
Yeah, it's
and it's just
bi-directional. That's true. Yeah, that's
all right.
so we humans are trying to create these workflows that we're trying to
Right,
prevent
right.
ourselves from screwing up.
Well, and then they're trying, like I always shake my head at the poor linguists that have like, translate these, 8 words.
Yeah, yeah.
It's just a terrible project in my mind, but it happens. All right. Some companies build their own Git connectors. What other types do teams? Well, this is kind of got screwed up, my fault. Let's just say you're building your own Git connector. What are the things you have to like watch out for?
Well, okay.
And what other connectors, are people commonly building in-house?
So I think I'll answer that more as a starting off with a buy build kind of question.
Yeah,
And
that's really what it is.
yeah, and I think there's different ways of tackling this. I mean, a connector is essentially a bridge. It's a middleware bridge. It's something that is kind of an independently managed system that has, as you said, 2 foots on either side. You have one on one end, one on the other. So that bridge has 2 foots. The feet both need to be robust, and they're different. They have different challenges going each way. So the traffic going on both directions is different. If you have good in-house development resources, it can make sense to go straight to API, build your own ecosystem, your own controls. I think that makes sense as your aptitude is higher. If you have complex internal infosec requirements or complex intersystematic challenges, and again, I'm speaking on as I sort of think about years of working with various different client ecosystems, some of which are nicer than others. The ones who have their act together and are more mature basically become invisible from the downstream side because everything's feeding into it in a nice, clean kind of way. I usually hear about it when it's not that clean, not well organized. So you see the consequences of a kind of a sort of unstructured stuff getting thrown over the wall downstream, and then the chaos that can include. So, getting back to your question, there's three basic ideas that you either build or buy a connector, so this middleware, or you can build the direct connectors yourself, like go straight to different systems via API. I think a lot of developers would prefer to do that in some ways because it's direct, but you have to own the consequences of it, and you have to build all that kind of robust error checking yourself so that you own kind of that process. And then I guess the third layer is there's a whole class of automation capabilities now out there that are, I was thinking kind of the orchestration layer of things. There's a bunch of different systems out there that are looking at orchestration at a high level. Some of those systems are quite complex and expensive to operate, and you need special skills to be able to configure them. So at a high level, each of these options is, I would look at it as a business analyst, kind of looking like what's the volume, how much internal technical capability do I have, how much time am I saving, and whose time am I saving? So again, looking at the internal engineering standpoint, internal engineers are very expensive. Like I consider them one of the most expensive resources. I even had a client once for whom I saved $100,000 a year, and they didn't want me to include it in the QBR because it involved a little bit of time from one of their engineers, and it was even a little bit of time. 100,000 was not worth it. So you can get a sense for how some companies kind of value their internal engineering overhead. So much easier to externalize it by having an outsourced entity deal with it that you can swap out or manage or control via contractually or systematically control as a supplier. So I wandered all over there, Adam. I mean, I think whenever we talk,
Well,
whenever you talk to me in general, it's like
I
I get.
understand. I mean, the thing that I also see in organizations is they have somebody goes, they have a localization engineer, they go and write some connector, and that's great. And then that person leaves the company for whatever reasons.
Yeah,
And now there's nobody who knows what this thing is and how do they maintain it. And then something breaks.
yeah,
So for instance, you see movements from a security perspective, for instance, like Jenkins dependent systems and then Jenkins becomes a security liability for this version, but then nobody's around to update it. I mean, localization departments are by nature kind of shorthanded.
yeah,
And I've seen, well, I can even name a few of our customers that are like multi-billion dollar worldwide companies. And there's one localization person in charge of all that. So automation is pretty critical to that person, but also they just can't deal with like, oh, this person left. Now nobody's maintaining this,
hmm
So
yeah,
so
yeah,
that's a consideration for some companies. I mean, you mentioned a few things so far: version control, delta management. I'm going to add file formatting. Whether it's Git or other areas, it's a lot easier if you can convert a file format versus getting an entire development team to change their practice. So French from French is FR instead of just FR or
yeah,
something like
yeah.
that. I mean, you see these things all the time over the years.
Sure.
So
You're hitting
um,
on something really interesting, which is the standardization question. And
right.
you know, if a dev team has a unique or complicated internal structure, they may want to build their own stuff because it's so specific to their unique ecosystem.
Mhm.
I mean, if
Right,
you build
right.
your own, you have more control over when and how strings are extracted, and you
Hmm.
have all kinds of
Right,
custom,
right.
and then when you get to sort of markdown files, formats, or JSON, YAML, PO, regex, they all have a lot of string logic in them, each of which is unique and potentially complicated. So you can write Python scripts internally that will push stuff to xlif, and boom, you're already done. However, having a connector can kind of be an easy button to plugging these things in, helping somebody else configure to your dev team's
Hmm.
preferences, and coordinating that out. So and there are different kind of connectors out there. Some of the large TMSs have native GitHub kind of connectors that they have, but there's an effort to configure them, and there's the ownership and the maintenance of that. So that's something that any buyer of a connector should think about: is who owns it, who's responsible for it, who maintains it. And by maintaining, getting back to my broom analogy, whenever anything changes upstream, there's software updates, there's new kind of changes to the data structure upstream. Who's going to modify your downstream
Hmm.
expectations to it? And
Hmm.
I think there's several different attempts in the industry before, where to be a connector hub, like to be a company that sort of does all connectors and kind of handles that. It was very expensive to own that, and it's sort of the buyers often are shocked, get sticker shock on how expensive these things are to own. There's a data exfiltration kind of mindset of like, how do you take content out of some space efficiently? And by efficiently, I mean the right strings, the right time, the right cadence, all the things that you need to think about, and move them over to a different place. But I just want to reemphasize that there's the bridge is that upstream side is, how do you plug into what to translate and how to translate it, and like, how do you manage those strings? That is a non-trivial task, and LSPs for the most part don't want to deal with that.
Hmm.
I'll put that out there. We don't like to deal with it. Like,
Hmm.
we'd love to have TMSs or somebody like Lingoport or somebody else to deal with that, so that we can focus on what we're good at, which is taking strings and providing the right context to them, and distributing that task to translators or to automated translation, which also needs that context. So, like, we see this with AI translations too, that context still becomes incredibly important in getting to the right answer. So the noise of the where the code lives to
Hmm.
the place where the translator, or automated or otherwise, lives, that bridge is still hugely. I'm getting to. I'm already starting to think about why we're doing this, but the root of it is still pretty critical to sort out. Yeah,
All right, I'm gonna move on. We both probably are talking too much. I want
I
to leave
am.
time for
Yeah,
questions.
yeah.
Well, no, I'm stoking it, so don't worry about it. I think we talked a lot about this, the build versus buy. So I think we included this. So I'm going to scoot by that. Okay, Git is near and dear to my heart. What are we might be summarize some of the things that we talked about, but common pitfalls, surprises, and success stories you've seen.
Mhm. Well, I think the success story, I'll start there, is when essentially the problem goes away from a business management standpoint. So let's
Right,
say
right.
it's successful when it's invisible. We don't really want to be dealing with this. We don't want time consumed by it. So when it is working and working correctly and isn't throwing errors, that's what success looks like. And then I think it can be tempting to start saying, well, why are we spending this money? Because we're spending money on a non-existent problem now. I can see that logic. Like, again, I'm channeling my inner executive. Like, why do
Uh-huh.
I have to spend this money to do something that isn't actually doing anything? But so it is a challenge, because you have to try to justify the absence of something that you're successfully avoiding. Now, that's what success looks like. Often, the times when people need this the most is when they're they're struggling upstream with delta management, with version control, and they're finding that they have to spend a lot of internal hours, some internal overhead internally, like their team has to spend a lot of time bundling things up, sending things over, and then realizing something got missed, or downstream engineering hours. And I mean, with LSP engineering time, whether you have a large amount of engineering hours, it takes a long time to prep or a long time to post process. These are signals that you could do better with a connector. Now, this is where the cost shift is, right? So either you're paying money for a good connector that's robust and has the right scalability, or you're spending money on labor internal, either to your internal team, kind of figuring out what to translate and how, or on the downstream side, your LSP is spending a lot of hours charging you those hours. And some companies are fine with that. They'll just make the problem go away, just send all the work over to, the engineering hours aren't worth it enough to them. They'll just pay for all that extra engineering time. But it's really unfortunate because they are, I think it's relatively short-sighted to settle for a manual process when an efficient process could replace it. So, but there is an ROI that, like, some connectors are exorbitantly expensive. So maybe it is cheaper to do it the manual way. So, just to keep that in mind.
I had a client liken it to when it's set up. It's like when you walk into a room and they're at your office and there's a light sensor and it says, "Oh, time to turn the lights on," and you don't think about that after a while. And then when you walk out, it saves energy, turns off.
Mhm.
Like that. I mean, the real life that I've seen, like extremes of is when like we have a client and they have hundreds of software projects onboarded, and they're just one person and they're able to manage essentially hundreds of repos
Yeah,
getting updated. And let's say it's 85 products or whatever the number is. It's a
yeah,
lot of products, and yet that train is working well, because like for instance, let's talk about error handling. If there's an error, um, it gets flagged, and it gets flagged not when it's too late, but when it's active.
yeah,
So um, proactively, the localization manager can actually see it coming, and they can say,
yeah,
"Hey, there's an error in this file on this line. Here's what it is. Let me Slack it to you." Blah blah blah. It's a very quick fix, right? Well, what happens is when that happens over time, those errors go away because you have a full feedback going on to
mhm,
developers. And so that's good. It's the same for like our I18N tools like Globalizer. If like if you're a developer, you don't want that little red mark on your pull request.
yeah, yeah.
It's self-regulating because, okay, I've seen this before. Don't do that.
Sure. So you're hitting some key points here, like
Right.
the pitfalls. The human factor is a big part of it, and then overlapping
Right.
responsibilities between project managers and their responsibility to sort of monitor tasks and the engineers who are trying to
Yeah.
deliver code. These are each distinctive, and having something that kind of orchestrates the way that these roles fit together is really important. I think the assuming the systems speak the same language can also be
Mhm.
a huge headache. And in this case, I'm drawing a metaphor between the language of a project manager and an engineer versus the language of a code repository and the systems that are
Mhm.
designed to handle the round tripping of string translations. I think metadata and how it's handled and nuance of different subcategories, is the metadata translatable, or is it localizable, or is it relevant at all? What do you lock? What do you not lock? How do you
Mhm.
how do you
Mhm.
control the system limitations, like string length limitations and things like that? I think another pitfall is not clear governance over, like, the big picture understanding of what you're trying to achieve. Scaling problems, misaligned is, getting unclear with regards to what you're trying to achieve. And that's kind of my thesis every time I talk about anything solutions, is understanding the why of what you're doing. To it. But the things that blow these things up are humans. Like, they keep on adding a level of chaos to it. So communication becomes the roadblock and clarification. You hit on something really earlier that I really like, which is, somebody builds a system and deploys it and then leaves the company and nobody knows how to use it anymore. So that kind of home built little fragile duct tape and glue solution, or even buying a complex software package that they don't know how to implement or manage internally, can be major roadblocks. Security is an issue. Yeah, I think there's also an an overwriting problem, I think, where managing the what is being pulled from repository and then goes to a translation cycle and then gets put back again. You can run into situations where sometimes you pull something that's already been translated. You don't need to pull it. Then it goes through and actually introduces an error because it hasn't really been locked out correctly from something that should have already been handled. So content management systems, or there's like things like this is old school, but Vasant kind of kept all the strings in a giant database. They never even sent them to translation because all the localized strings were already in the system. You never had to round trip them at all. So a successful sort of deployment of a software localization system is not to send things you don't need to touch. But at the same time, if you do that, you're only pulling strings that do need to be touched without that full context. That can be a problem too. So now you have the sort of the object, which might have only one new sentence in an entire sort of dialogue box or something. You only send that one segment, you no longer have that full context. If you send the full context, you're exposing it to error throughout that whole life cycle. So controlling that whole process is non-trivial. So I mean, getting to how many ways this can break, it can break in an awful lot of surprisingly large number of ways, which again is why the maintenance becomes so.
When you talk about deltas and synchronization and context, context keeps coming up in the language of the answers, and I'm gonna say that there's been a pretty profound shift in the way software is made. That's happened, and it really was starting before COVID. I remember being out with a friend of mine who was a software designer, and he says, "Oh, we don't let any developer write a string. We plan it out in Figma, and all those strings are all accounted for, and they're and that was really early on. That's becoming more normal, that you design in Figma, you lay out all your strings. So like for instance, Localizer connects to Figma, and it also gathers the context of the Figma layout, associates it with a string, and then it goes even one step further. It creates the localization object. So because in the past, like you might pseudo localize off of Figma, or you might machine translate off of Figma, or even translate, but those translations might get thrown in the garbage because they weren't available to the developers. We create a persistent object that goes right into GitHub, and it's there for the developers. So the developers just call that in their application. They don't have to recreate that whole system. It's built for them,
Yeah.
so to speak. But the main thing also here is that context is something that if you wrote your own, you couldn't have foreseen that years ago. How do I collect context of what the string relates to, without creating a burden for the developers?
Yeah.
Because once you create a burden, and you have scale, and you have teams all over the world, blah, blah, blah. It's one thing when you have a team of five. I mean, a team of five Java developers, or the like, can get a lot done, right? But once you have scale, and you have people all and hiring, coming and going, it's very hard to enforce, hey, grab a screenshot of everything you do manually and associate it with a string. I mean, that's hard to do. So making that simple, and why that's so important, especially going forward, is you needed it for humans. Well, you need it for machines now too. I mean,
You do. Yeah.
We're going to be talking about that in early December because we have a whole research project of associating various forms of context with strings and how AI reacts with that, and that'll be a pretty interesting webinar. But I'm
Yeah.
more about that later in November. Anyway, um, I'm probably going to go through this fast. Asynchronous operations. What we mean by that is Erik brought that up. Um, they send something out and then they go, oh, hey, we need to make one more change, right?
Yeah.
And you see this, I mentioned like the designers creating all the strings. Well, there's always some error message. There's always some last minute change that happens when you create software. And that could come from the developers. It could come from anywhere, or conversely, you're supporting 24 languages and 23 of them came back and the 24th is behind and there's been another update and so that becomes super important with all kinds of content that's well handled and it's not easy. It's actually tricky. So
Yeah, it's a lot harder than people perhaps think. So yeah, we start off with what's a connector, and now you're getting
uh,
into nuanced issues about when individual strings get updated, and then the out of sync. There's problems because this is a simple version of the problem. There's an extract of a string, and now it's going into a localization pipe that let's say it has 10 steps, and each of those steps, and then there's an update. So then, well, don't translate that one. There's a new version of this string. So see, you can do several things. You can either stop that clock, that sequence, which is moving from prep it, send it through your TM, maybe throw it into a MT, maybe send it to a reviewer, second reviewer, blah, whatever that workflow is. And then all the payment and tracking and things that are involved with that. Or you say, stop, we're going to cancel that, go back to zero, might have to pay a little bit for the part that you've already done, and then restart the clock. Or you finish that clock and then you start a new clock, a new cycle. Or you can interject it at some stage with some logic to say, okay, we've gotten this far in the process. Now let's sort of swap this out. And I've seen both humans and machine solutions get snarled with this kind of logic, and it gets to bewilderingly difficult to unblock that. So if you have a fully automated system that can do this more or less instantaneously, that becomes a much, much simpler process. It's much easier just to finish the cycle or just cancel it than it is to sort of figure out where in that cycle to implement things. But the asynchronicity of it and the systems talking to each other and understanding the language of these disparate systems isn't just a matter of the software. I think Alex threw a question in here that I think also speaks to the importance of the business entities understanding each other's respective constraints. So as the loc manager on the LSP side needs to understand the software development cycle and what the consequences of certain decisions are in that life cycle. And if you're building connectors, you make that connector logically consistent with those priorities. So the update and versioning cycle is exactly where that matters the most, I think. And on the flip side, it's also important for software developers to understand the consequences of various things and how the localization system works and how that internal clock runs, so that as they're sort of setting up the technical ecosystem to support this, that they've thought about how all this logical flow works and what the consequences of these updates, merges, deviations, lots of risks that need to be managed in this complexity.
okay, good. Um, uh, let's see. I think this is, we've got a lot of questions left. So let's try and do these last ones pretty quickly. Since I think that we've kind of addressed some of these, like what challenges do file formats create and how do connectors solve them?
Yeah.
Um, I mentioned that it can be hard to get developers to all use the same, let's say, locale format or file format issues in how they implement things. And it's easier to transform those into something that can be digested, let's say by a TMS or a translator workbench or whatever. It's easier to instead of getting the developers to change what they're doing, to transform it, it gets worked on, and then transform it back.
Yeah,
You know,
yeah, yeah,
so we have a lot of functionality to get that done, and sort of locale mapping, making that easier, like point and click and change that rather than even like having to write a Python script. I mean, literally type in the source. Here's where the repo is. Nobody has to mess with the API, and this is the format that I expect. I'm going to transform it into that, and
yeah,
here's the locale. What it's going to map to.
yeah,
you
yeah,
know.
totally.
So
So
yeah,
totally, and I think again, you're getting into that question of how much do you want to ask the upstream side to normalize and
right,
provide
right.
easy to consume downstream content versus
Mhm.
what role does middleware have in normalizing that? So that all the different
Right.
delta over here can be normalized here, and then that pipe out to the localization cycle is nice and clean and
Right, right.
consistent. Yeah.
And let's remember that there's a lot of legacy involved in software, and often the localization manager, like we'd like them to know, but they're often the last to know.
Yeah.
And something like that is going on.
They
All right,
often don't know, and they often that's not what we're paying them to do. Like
right, right.
and the more specialization there is in a complex system, the more likely individual seats at the table will not have the full context of
Hmm.
where this goes. So the more complex the system, the more necessary it is to have automated systems to support that complexity.
Right. Alex, under the question interface, really kind of laid out a lot here, even more than what we've talked about,
Mhm.
merge conflicts and the like. So
Yes. Yeah.
branching, he mentions, all of that comes into it. Branching is a whole nother conversation, which I don't think we want to go there, but that's a matter of like localization managers actually understanding the mechanisms of continuous engineering
Yeah.
and approval processes and merge processes and the like. Um, I think this is all right. Just API versus point and click.
Yeah. So, I mean, there's at a high level, the API question is it's an endpoint, right? You can interact with that endpoint. I think there's different sort of method. I think why this is so hard to really answer is because there's are different ways of doing the same thing. Ultimately, you're still moving things from one place to another. You're still kind of sending a push or a pull to, start a sequence of steps at its
Mhm.
root. So, the connector is kind of the API is a place where things can get pushed or pulled from. And I think it's an important part of our ecosystem. Most orchestration layers benefit from subsystems that have robust API systems. So you think about a Blackbird or systems that are designed to be orchestrator layers. They can do a lot if they have an API connector to these different subsystems and can move things around in a very logical and really interesting way. Um, so API is an important part of that process. I think a connector can be a bridge. You think about a connector being a bridge, and an API is, I think, a foot of a bridge where something can bridge to it through that interface. So you
Great
can build that
analogy.
bridge yourself, or you can use a middleware to do that. But the same API footers that you're connecting to need to be robust enough and relevant enough and have the right metadata and the right sort of data structure to align to. And that mismatched data structure is, to me, one of the biggest headaches is where you have different shaped objects that you're trying to fit into different shaped holes. It gets to be, you have to add more and more layers of complexity to deal with and not the misalignment of those different system values.
I mean, what I'd say about APIs is it's often sold as really simple to implement, and the reality is 3 weeks because of
Oh,
corner cases, human delays, issues, and that. So I see like when we manage an API to a TMS or something like that, I always figure this could be 3 months just because of back and forth, human error, poor documentation. It's your test environment, it's your corner cases and all that.
yeah.
I'm not down on APIs, but I think they get sold as slam dunk, and they're not, you know. So
I think you have, I mean, you have potentially more direct control, right? I
mhm,
mean, again, wearing the hat of a developer, you know what you're dealing with and you can interact with it the way you choose to.
mhm,
I think the
mhm,
dev effort is a little higher up front. I think it requires internal engineering and API expertise. So I think you have
mhm,
to have sort of some deeper knowledge about what's going on to support them.
mhm,
And of course, maintenance is an issue. I think larger enterprises with their own IT teams, I think are better fit for solving things that way with an internal
mhm,
uh,
mhm,
deal with the internal steps and then interact with APIs for external
mhm,
layers. I think the middleware or the connectors each have pros and cons too with regards to kind of what you're paying for versus what you're getting for the individual thing that you are trying to achieve with it. So you could, I mean, with an API approach, you might need just one thing and you can build that one thing. If you have a more complex system, you don't, with that one thing, you don't need a whole connector system to support it. But if you have, and if it's infrequent and if a manual cycle is fine, but the bigger it gets and the more complex it gets, the more it makes sense to have middleware support. Or if you have the muscle internally to build these things, the most mature, larger enterprises build their own kind of entire ecosystem. They need that level of control, like
mhm,
for
mhm.
various reasons.
All right. So I'm going to skip this question because we kind of talked about it a little bit. And we're actually at the point where if people have a question, this is a great time to give it. I might read aloud Alex's question just because, well, it wasn't really a question. It was really more of a statement, but it's well worded. Did you have anything further to add before I go on to that?
Um, Only um, that the number of permutations that even a single ecosystem could have with regards to the internal, like Git is a structure. There's CMSs have structures, AEM has structures, like all these, they have
Mhm,
tools, and there's a there's a level of customization that you allow your creators to have. And the more of that creative control they have, the more ways a connector is challenged to interact with it in a systematic way. Equally, if you make it easy for the connector, you sometimes put handcuffs on your creators. So the creators end up doing things that are very kind of antithetical to your best needs of your end customers. So there's trade. It's challenging, and I know this isn't a Git question, but there was an art guy Taos who's talking about articulate, and he gave articulate as an LMS, and he was talking about how the creators can design an interface in which you have a rich visual experience. You can click on things, pops out all the contextual support clues. There's sort of a even graphic 3D representations of things. Each layer of it's not just text, right? We're dealing with a visual context of a UI or some kind of visual interface. And when you add a localization system that only consumes text and can't handle the graphic contexts, then what you end up seeing, and the night showed us, was a text heavy screen with nothing but a bunch of strings on it. it was terrible. It wasn't, it was dense text, but they did that because they were forced to, they had to localize. So they forced themselves to write in such a way that it produced an extremely low user experience. So I guess what I really wanted to get out there is that we're not just dealing with strings, we're dealing with an entire user experience.
Mhm.
And I want to add another layer on top of that, which is we start with this assumption that the source is 100% correct and that all the targets should be identical to the source. But I think as AI is using generative AI in particular, creates an opportunity for locale specific user experiences, we could be dealing with a much more complicated situation where it's not just a pipeline from English source directly to identical target locales. Changes or customizations on all those other spokes that now they need to be integrated back into some kind of way of reconciling all this. And right now I'm looking ahead right now. I don't think anybody's really figured this out yet. This is more like the problem that's emerging is the multimodal data getting through from a text-rich, we live in a text-rich, text-focused world. But I think the multimodal, multimedia aspects and how to track these different sort of data stream types, and the fact that you could have asynchronous target outputs for each of the spokes on your global distribution landscape it's going to keep us busy for a while, Adam. I don't think we're
Mhm.
going to run out of
Mhm.
problems in this space. Anyway, if you want to switch to Olex's thing, that's fine. But yeah, I think we're almost all out of time.
Well, you're kind of pointing out that this whole AI thing, well, I shouldn't just call it a whole AI thing, but this AI opportunity right now, everybody's talking about it, and a lot of the people I didn't go to World this year. I had other conflicts and couldn't go, but it seemed every presentation was AI, but a lot of that is thought of in the construct of how things have always been done. So we're going to apply MT, then use AI to score it. And what you're speaking about is something new, which is um, we're going to look at the source. We're going to consider what is best for this locale, and possibly even a level of personalization that we couldn't enjoy. Now, all of this stuff, it takes humans a while to absorb all this and new technology, and it takes a lot of research to actually see is this better?
Hmm.
Just
Yeah,
because you can doesn't necessarily mean it's better. And so you've got to do that research that says, yeah, this is a better process, and the world will respond to this in a way that makes it worth doing.
yeah,
So that's a whole nother conversation, but it's the sort of thing that gets my juices flowing quite a
yeah.
bit. So
And you have people
yeah,
generating code with AI like to rapidly build and deploy things. I was talking to a guy at a
right,
roundtable a couple of nights ago, and he was spinning up software with AI support much faster. So now you think about the globalization challenges of this sort of fast dev
right, right,
ecosystem, where you
right,
might even think about one-off localization rounds, and you basically
right,
deploy to, and then you just do the whole thing each time. Like you don't even
right,
try to
right,
update everything.
right.
You don't worry about TM. You're just AI
Yeah,
translating everything every time, and then you're just updating the core language assets at the heart of it. How do you manage the workflow in that kind of ecosystem?
yeah, yeah.
It's really
Right,
fascinating. I
right.
don't think we've really even touched the surface of it, but it's a great topic to close on because as we think about kind of constraining a traditional localization process and all the challenges associated with it, which are considerable, we have more complexity heading for us, not less.
Right,
Yeah,
right, right. And speed. Speed starts to be more and more, which I like speed because in my mind, like one of the basic agile principles is you create something and you can demonstrate that it works, right?
yeah.
And you have that feedback loop of yes, this works, or it doesn't work, and so I need to correct this, right? And you
Mhm.
do it in little increments. That's basic agile. manifesto from like 1999, right?
Mhm.
Um, and if localization is always dragging and waiting till development is complete, which less and less is the case, but it's kind of still how it works for most organizations. You're outside of that agile feedback loop, and that
Yeah.
creates its own, and it limits what you can do with what we're talking about going forward. So it's more and more important that localization is fast and it meets now it's the opportunities is fast and it's cheap and is quality good enough?
Yeah.
That's a whole nother webinar. So let's not do that. But I'm just going to read what Alex wrote. I think I'm going to close it off of that. A thought, not a question. He writes, things with Git can get pretty complex for translation management. One super important thing is the loc manager needs to understand how the internal software development lifecycle works, what engineers do, how they do it. I have to say that for some, I have to say, localization managers are getting increasingly technical comfortable. And that's a big difference between 10 and especially 20 years ago that, you and I have been around this industry for a while. It used to be that if I said a word like compile, eyes would glaze over, let alone pull request and that sort of thing. But
Mhm.
that's less, I'd say there's been a lot of improvement, but the issue is that a localization manager is often somebody who's studied a language and
Mhm.
sort of fell into that as localization. So they speak Spanish really well, but not necessarily software. It's a different set of expertise, but they're smart people by nature, I think. So anyway, when setting up any Git
Mhm.
connector, the following use cases and concepts will inevitably come up. Rebase, merge conflicts, race conditions. What is the base commit? Which branches are translating? How are merging into production? Who is merging, especially when your org is SOC compliant, et cetera, et cetera. So it's just really, yeah, this thing is complex. It's more than just, hey, the original way of let me send files or upload these files. So
Right. And I
that,
would like to close on that thought
yeah,
too, that connectors is not just it's not a Lego. It's not something you just plug in a cable
right.
like an extension cord and you've got two systems connected. The only reason extension cord works is that you have a super normalized system. But in the complex world of software development, connector is not a simple, plug and play thing. There's different levels of complexity. There's different areas of focus from time and space and complexity constraints. And I
Mhm.
think, overall, it's a great place to start the conversation about
Yeah,
how do we create business value through automating certain tasks and start there. And that's
right,
always where I start is where I always end every conversation with where to start. So anyway,
right.
nice talking
Very
to you,
good.
Adam. It's a pleasure.
Very good. Thank you for our conversation, Eric. Always a good time being with you. And if people have questions for me or Eric, you see my easy version of my email on the screen. Just send me something and I'll pass it on to Eric, or if you have a question for me. Thank you, everybody. Quite a few of you stayed the whole time, so I appreciate that. All right. Take care, everyone. Bye-bye.
Have a great day. Bye bye.